Okay, this is how we work through problem number 14 on the quiz. I'm going to be using different numbers than are on the quiz, but the setup is exactly the same. Our first step to every problem is reading the question. So let's do that. If you throw a ball straight up at a speed of 10 meters per second, I'm going to use 80 meters per second. How long will it take to reach zero speed? How long will it take to return to its starting point? How fast will it be going when it returns to its starting point? So our next step in every question, or every problem, is rereading the question and identifying given information and requested information as we see it. So let's go through again. If you throw a ball straight up, so we're talking about a ball here, not a rocket or anything. All that's acting on it after it leaves our hand is gravity. So we know that acceleration is 10 meters per second squared. Always. If it's just a free fall situation with a rock or a ball or whatever, the acceleration is 10 meters per second squared. That's the acceleration due to gravity. So when a ball is thrown straight up at a speed of 80 meters per second, so that's our speed or velocity initial, 80 meters per second. How long will it take to reach zero speed? How long indicates a unit of time, so we're solving for time. How fast will it be going? Oh, how long will it take to return to its starting point? So we're going to find two different times. How fast will it be going when it returns to its starting point? How fast indicates velocity. So, let's think about this situation. We throw a ball up, and it comes back down. Here, when it leaves our hand, it's going 80 meters per second. We need to find the time it takes to reach zero speed. Where is that? It's going to continue going up, and then when it turns around here for just a snapshot in time, its velocity will be zero. Velocity final, sorry, that F is kind of messed up, but it's okay. Velocity final equals 0 meters per second at the very top. That's where it runs out of speed. So if its velocity is 80 meters per second, and the velocity is in the upward direction, and our acceleration is 10 meters per second squared, that's 10 meters per second every second, and it's pulling it down. How many seconds at 10 meters per second does it take to cancel out 80 meters per second? 80 meters being scrubbed off at 10 meters per second, that's 8 seconds. Meters cancels, one of the seconds cancel. Oops. So there's your time for it to reach zero speed. Now, you're familiar with the old saying, what goes up must come down. And the only force acting on it as it's traveling up is the acceleration due to gravity. The only force acting on it when it's coming back down is still acceleration due to gravity. If the forces are exactly the same, then the time to cover the distance should be exactly the same, and it is. So 8 seconds, 8 seconds up, 8 seconds down. Now again, if it was going 80 meters per second, at this point, coming up, how fast will it be going at the exact same spot going down, being acted on by the exact same forces? 80 meters per second. You can also solve this using VF. This is on your sheet, on your quiz. VF equals V naught plus AT. With your final velocity being here and your initial velocity being here. Your initial velocity at the very top of the trajectory is 0 meters per second. And your final velocity is what you want to find out. So VF equals 0 plus, what's the acceleration? Right here. Multiplied by time, which you figured out is 8 seconds. Ten times 8, 80 meters per second. I hope that helps. If you have any more questions, let me know.